to show you, and I'll take your questions. So, okay, so there's, oh, you can't see what I'm looking at. There's a good way to do this. How do I do this? Aha. Beautiful. Okay, so there's this really, really amazing website that I've discovered called the National Library of Virtual Manipulatives. So if you're in a classroom where, oh, am I recording? I think I am. Okay. Well, no, it'll follow me regardless of if I'm recording. Okay, cool. So regardless of whether or not your future classroom has base 10 blocks or literally anything, it's okay because you can use this. So this thing has base blocks for you to do stuff with division. Place value. And it has fraction bars, fraction naming, parts of fractions, right? So all of these really cool things, number line arithmetic, we'll jump back to that in a minute later today. Number line bars, fractions. Check this out. Okay, so look at this. It's already up here. Okay, so what is 7/5 divided by 1/2? Well, that's how many 1/2 bars there are in 7/5, right? And so you can see, like, 7/5 is here, and then I've got my half bars, right? And so then I'm trying to figure out, well, how many half bars fit into this 7/5? So I've got 1, 2, and a little bit. But how much is that little bit? Well, if I think about this rectangle as my whole now, it's divided into 1, 2, 3, 4, 5 pieces, of which 4 are included in the 7/5. So 2 and 4/5, 1/2 bars fit into 7/5. Which means that division is equal to 2 and 4/5. Cool? So then if you're like, okay, well that was a pre-populated problem, so how would you use this tool? You'd say, okay, well let me clear everything, okay? And let's say, give me a fraction that you want to divide. Any fraction. 1/3. Okay, so what would you like? So I said 1/3, so here's my 1/3. What would you like to divide 1/3 by? One-eighth? Okay. So I'm going to create a new bar that's 1/8. We'll make that yellow just so that it looks different. Okay, and so now notice when I line these up, my grid marks no longer align in the way that I want them to. Oh, there's going to be a problem here. The step size maxes out. So the step size is what determines how wide these grid marks are. And I think it only goes up to 15ths. Yeah. Okay. So do you know what step size we would need for 1/3 and 1/8? We'd need 24ths. Okay, so that's okay. We can select that guy and delete him. Let's maybe pick a different one. Let's do 9ths. Okay, so now I've got 1/9, and I want to figure out how many times that goes into 1/3. So then do you see what happened? So when I got to 12ths, the grid mark lined up with the thirds, but it doesn't line up with the 9ths, right? So I'm going to keep increasing my step size. Now when I'm using a step size of 1/9, I actually, everything fits nicely in the grid, right? And so then I can say, oh, okay, cool. So I've got one copy of 1/9. If I use a second copy of 1/9, And then if I use a third copy of 1/9, sweet, I get 3 copies. So 1/3 divided by 1/9 is what? 3. Neat? Probably a little bit friendlier than the drawings I was trying to do on the board last time. Yeah? So yay for the power of manipulatives. Even when they're not like in your finger. Well, they're kind of, using my okay, so that's a cool thing that I thought you guys should see, because look at how many of them there are, right? So if you ever find yourself thinking like, man, what could I do to help kids play with this stuff without go out and buy a ton of materials and spend hours of your life creating packets of things, you could just do this. Right? Okay. There was another thing that I wanted to show you to try to convince you that this is all worthwhile. So here's a child doing some division problems. And I want you to just like soak this in for a second.
Can you work that problem, Elliot?
Whoops, sorry.
How did you get that so fast?
1/3 goes into 1/3.
Can you hear that?
You dropped it, so what have you dropped?
1/3. And it goes into one hole. I combine the thirds 3 times because I've got one of these. This will connect to this one. This will connect to that one. And this will connect to that one.
Is that what division means?
Yeah, how many times that goes into that?
Okay, nice job.
Okay. Could you hear it? Like, was that not the coolest thing you've ever seen? Okay, let me try not to blow out our eardrums because I just connected it so it'll be the classroom speakers. But so now he's doing a new problem, 1/2 divided by 1/3. Okay, and he just did 1 divided by 1/3. Whoop. Oh, it didn't like it. Oh, because.
Can you explain your answer?
Right up here, all you did was add 1/2, so the answer was 3 if I didn't have. If this was not there, the answer would be 3, but that is there, and 1/3 goes into 1/2 one time, and now that I've got 1/6 left, 2/6 equals 1/3, and 3/6 equals 1/2. So I take away 2/6 because I've taken away 1/3 out of the 1/2, and I have 1/6 left.
I see, just how you thought about that.
He did that so freaking fast. You want to see it again? Okay, did you catch the first part of his strategy, though? The first part of his strategy was to say, well, the only thing that's different between this problem and this problem is the 1/2. And I already know from this problem that 3 copies of 1/3 fit into 1. So all I need now is figure out how many copies of 1/3 there are in 1/2. And then he starts going really fast after that, which is like, whoa, you were freaking smart. Okay, so that's, hopefully that'll help you get like into it a little more, okay?
So the answer was 3 if I didn't have. If this was not there, the answer would be 3, but that is there, and 1/3 goes into 1/2 one time, and now that I've got 1/6 left, 2/6 equals 1/3, and 3/6 equals 1/2. So,
Are you keeping up? So 1/3 goes into 1/2 one time, and then there's 1/6 left. What is he imagining right now? So you've got 0 to 1/2, and this is 1/3. So there's my one copy of 1/3 in 1/2. But then how much is this? How big is that? The gap between 1/3 and 1/2? How do you find that value? Or how do you think about that value? Okay, common denominator. So you have 3/6 and 2/6, right? So 3/6 and 2/6, then what's in between is 1/6, right? So that's what he meant when he said there's 1/6 left. Okay? So now we're trying to figure out, okay, I've got 1/6. How much of 1/3 is 1/6? That's what he's doing now, okay? Right? So, and now that I've got 1/6 left, right? Let me back it up just a little bit.
And goes into 1/2 one time, and now that I've got 1/6 left, 2/6 equals 1/3, and 3/6 equals 1/2. So I take away 2/6 because I'm taking away 1/3 out of the 1/2, and I have 1/6 left.
So he just explains this, right?
Nice job.
Oh, wait. Nope.
The answer would be 3, but that is there, and 1/3 goes into 1/2 one. Now that I've got 1/6 left, 2/6 equals 1/3, and 3/6 equals 1/2. So I take away 2/6, taking away 1/3 out of the 1/2, and I have 1/6 left.
I see just how you thought about that. Nice job.
Do you see it? The answer is 4 and 1/6. That's the kid's answer.
So when he was doing that last part, he was just explaining how he got the 1/6 and wasn't like breaking it.
Mm-hmm. Okay, now here's my question. Is his answer correct? So if you were measuring this using this ruler stick, how big would it be? Yeah, my question was, if you wanted to measure this length using 1/3 as your ruler stick, what would be the measure of this length? So 1/3 is what we're dividing by, right? So that means I'm using the 1/3 as my ruler. So I've got one copy of 1/3 here. Now if I move my ruler and I say, okay, now I need to measure this red length, how big is that red length relative to my entire ruler? It's a half. Okay. So he didn't actually get the right answer. But for this kid, I am fully confident that it would not be hard to have that conversation that I just did with him because of the way he was already thinking about 1 divided by 1/3, right? How many copies of 1/3 are in 1? 3. Okay, how many copies of 1/3 are in 1/6? I think if you could just reframe the question out loud for this child, he would knock that out of the park, right? Because he's already got that way of thinking. I honestly think he got so wrapped up in explaining where the 1/6 came from that he just thought he was done because he gave that long explanation, right? Okay. But neat, right? To see a kid using that powerful of thinking. I thought that was amazing. So I wanted to share that with you. Okay. I'm going to put this link on our course website also, just so that you guys can go mess around with it, because I think, if nothing else, it'd be really useful for your own studying, right? If you're feeling like any of these things are still not where you'd like them to be before the final exam, then use it, right? Why not? Okay, that being said, are there any questions that you wanted to, if you didn't notice, I went back yesterday and I changed all of the due dates for old assignments to December 4th. That is the day before our final exam. I did that for 2 reasons, right? One is because I don't feel the need to penalize you for homework. So I'm giving you the opportunity to go back and get as high of a score on all of your homework as you want, okay? It is in your hands. But also, that's a great way for you to go back and start reviewing for the final. Now is not too soon to start studying for the final. If you haven't noticed, this is not the kind of math class where you should wait until the weekend before the final to start studying. If you do, you are shooting yourself in the foot, okay? Please start studying today, okay? Yes? I even reopened the learning curves. Yep, I reopened all of it. Okay. Would you like the homework before we take the quiz? Tracy?
Yeah, number 7.
In chapter 7?
Yeah.
Okay. Use 3 cups of hummingbird food, each fill the feeder. How many times can you fill the feeder if you mix 1 cup of food? This?
Yeah, I kept getting that one right, but it was the second part of it.
Oh, how many times can you fill the feeder if you mix 15 cups of food?
It said 2.5 cups on the page.
Okay. Just take a screenshot and send it to me, and I'll fix your points. Deal? Okay.
On number 9, it was like, okay, there was 35 students, and then half of them were girls, and then half, but if it was 35, I didn't know. There couldn't be even half girls and boys, if that makes sense.
It gave you 35 students, and it said half were girls.
Yeah, it was weird numbers. Or even 3/4, it gave me 14, and I was like,
That is upsetting. Yes. Yeah, I mean, if you got a number like 35 and it's talking about halves and fourths, that's not a realistic problem for this. So.
Look at it with the numbers. I just took a whole with a class.
Uh-huh.
And write it into a bullet.
ignoring reality.
ignoring the number, because it didn't ask for the number, it asked for the fraction.
Okay. So, yeah, so they shot themselves in the foot by giving you a number of students. Like, if I were to, okay, yeah, that makes sense. Okay, so, yeah, let's edit this problem. You should go back and read it as follows. There is a 5th grade class, period. You don't know how many students are in said class. Ignore whatever number they give you, okay? Just ignore the number. Now, a nice exercise for you would be to figure out what numbers would make sense to go in there, right? So if you had, for instance, 35 students, it would make sense to talk about like 3/5 are girls, and then 1/7 of the boys are into football, or something like that, okay? Such a sexist problem. Anyways, okay, so girls like football too. So yeah, so make that a mental exercise for yourself, okay? And then, but in order to get your points, what you're going to do is you're going to ignore the number of students that they give you, because you don't need it to do the problem, because they don't ever ask you, right? The question, if you look at what they're asking you, it's what fraction of the whole class are boys who like to play football, right? So they're not asking you how many boys like to play football in the class. They're just asking what fraction of the class, which means you can do the problem without actually knowing how many students are in the class, right? Does everybody have a vision of how you would do that without knowing the numbers? So you've got like, here's your class. Half of it is girls. So that means these are boys, because again, our book is not up with the modern age and doesn't think about gender identification, right? Okay, and so 3/4 of the boys in the class like to play football. So that means if I think about only the boys now, right, because it's 3/4 of the boys, right? So now let me think of this as if this were my new whole. And 3/4, so I divide into fourths, of which 3 are shaded, right? So 3/4 of the boys like football. But then the question is, now what part of the whole class? So zooming back out, so what part of the whole class likes to play football? Or sorry, is boys who like to play football? Well, out of the whole class, now in order to make this comparison, I need everything to be divided into the same size piece. And at the moment, it's not, right? Because these pieces are smaller than this chunk. But what could I do with this chunk? I could also divide it into fourths. And now we have equally sized pieces. How big is each piece relative to the whole? 1/8, right? So this is 1/8 of class, which makes this 3/8 of the class. So in particular, 28 is not a viable number of students for this class. You can't talk about, like 3/8 of 28 is not a whole number, right? So they definitely effed up their coding on this problem, okay? Sorry about that. What would be a viable number? For the number of students in the class. 24 would be a great one, right? Because you can talk about 3/8 of 24 and get a whole number, right? Is that the smallest number that you could work with? Could it be a smaller class than 24? Could have a class of 16. You could have a class of 8. Right? But that's as small as you can get for a class size and have it still make sense. You could go up to 32 and 40, et cetera. Okay, cool. Any other questions you want to talk about? Yeah. This is number 9. 29. You copy a drawing in a photocopy machine at the 75% setting. You lose the original. If you copy the smaller version, what photocopy settings will give you the original size? Oh, dang it. I can't, not show you the answer. I want to not show you the answer. So what's the temptation? First of all, does everybody understand the problem? So if you have a copy machine, you can shrink or blow up pictures. And the copy machine settings do that using percentages, all the time. I've never seen one that didn't use percentages to use this feature, okay? And so what you've done is you copied an image in a way that it shrinks it down to 75% of the original size. But now you want to blow it back up. So now you want to take the copied image and blow it back up to the original size. And so the temptation is to say, well, I shrank it by 25%, so I should just increase it by 25%, right? That's the temptation. But let me ask you, let's pretend for a second you make $10 an hour at your job. And your boss says times are tough. We got to cut some things. But rather than laying you off, I'm just going to reduce your salary by 10%. How much money are you making now? Now you're making $9 an hour. Okay. Now, business picks up again. Boss comes back and says, guess what? I'm going to do us all a solid and get us raises again. I'm going to raise your salary by 10%. Are you happy with your boss right now? Are you making $10 an hour now? No, right? Because it's 10% $9, 90 cents. So now your newly raised salary is only $9.90. You are still making less than you were before, right? Why is that? Why should that make perfect sense to you? When we do the first reduction, we're doing 10% of something that's bigger than what we're going to do a 10% increase on later, right? And percentages are all about ratios, essentially, right? So if I take a smaller thing, if I take the same portion of a smaller thing, that's going to be smaller than if I take the same portion of a bigger thing, right? Half of $10 is much less than half of $1 million, to make it exaggerated, right? Okay, so likewise, 50% of $10 is significantly less than 50% of $1 million. So every single time we talk about fractions, decimals, and percentages, we must make it clear what our whole is, right? When I say 50% of $10, the whole, the 100% would be the $10, right? When I say 50% of $1 million, the whole is now $1 million, right? Make sense? So in this case, in this example, we've taken an image So here's my original image, and I shrunk it down. I'm not doing this to scale, by the way, because when you shrink it, so here's what I don't want you to do right now. I do not want you to think of this as the actual image that you're shrinking, because if it were, then I would have to all of the side lengths have to shrink. So I'm not using this as you're shrinking. I'm using this as a representation of like the amount of original picture that you have. Okay? So 75% is the same as what fraction? 3/4. Okay. So 3/4. So now your new image is 3/4 the size of your original. Okay? And so now when you put this new image, this size thing back into your copier and you have to set the settings of how much you want to blow it up, now this new thing is your new whole. Notice your new whole is already divided into 3 equally sized pieces. And this is how much you need to blow it up, right? How big is this relative to this whole? 1/3. So you need to increase the size of your image by 1/3 or 33 1/3%. Now they rounded, right? Because they told you to round your answer to the nearest whole number. The exact answer, right? So the exact answer is to go from here back to here. You have to increase by 1/3 of shaded part, right? So I could think of this whole thing, so big rectangle is 4/3 of shaded rectangle, i.e., original picture, original size is 133 1/3% of smaller copy. Does that make sense? Cool beans? Okay. Are we ready to take the quiz? Let's do it. Okay. I'm just going to, I'll say it now. I'm really tempted to put something like this on the quiz, but because we hadn't actually done one in class, I decided that I could save this for the final, right? Because now we've talked about it. Okay. Whoop. Okay. All right, no calculators. No calculators.